Okay, grade 8, this is question 9 from the June 2019 exam paper. This is algebraic equations. We need to solve equations using inverse operations. So let's have a look here. Let's do 9.1. Remember, the first thing we do when we do algebra is that we always have to rewrite the equation. So it says minus 2x plus 6 equals 16. So now if you were quite smart, you could probably figure out what x is. Okay, I suspect it's negative 5, and that would be solving by inspection, but I don't want you to solve by inspection, because if you're looking at the question, you can see it's worth more than 1 mark, which means you need to show your working. So remember, this is a two-step equation. There's shoes and socks. So here are the shoes, the plus 6, and there is the socks, the multiplying by negative 2. So we need to do inverse operations to take the shoes off and then the socks. So the first thing we're going to do is try to get the x by itself. So there's a plus 6 on this side. So the inverse operation of plus 6 is subtract 6. Okay, so if I have plus 6 minus 6, then we end up with nothing on the left hand side here. So I end up with minus 2x equals 16 minus 6 is 10. Now this x is being multiplied by negative 2. So to get rid of the negative 2, I'm going to divide both sides by negative 2. Okay, negative 2. 10 divided by negative 2. And I end up with x, because negative 2 divided by negative 2 leaves me with 1. So 1x equals 10 divided by negative 2 is negative 5. Okay, so that's the first question, solved by inverse operations. It's one of the simplest ones. Now let's look at this next one, 9.2. To solve 9.2, first thing we do is we write out the equation. 2 minus x over 11 equals negative 8. Now this looks a little bit intimidating, but it's not really. It's still a two-step equation. Here on the left-hand side, I am adding 2. So if I want to get this x by itself, I need to subtract 2. So plus 2. If I do the inverse operations in another color, it takes me long. Okay, subtract 2. And then minus x over 11, I keep all the terms the same, equals negative 8, and my inverse operation is subtracting 2. So plus 2 minus 2 leaves you with nothing. Okay, so on this side I'm left with 0 plus minus x over 11, but I'm not writing the 0. Negative 8 subtract 2 is negative 10. Remember your integer rules. So now on this side, I am dividing x by 11. So if I say times by 11 minus x over 11, remember a fraction is dividing, and I times this side by 11, I will end up with, let's times by 11 on the other side. This pen color is a problem, so I'm just going to maybe later keep going with the same color pen. So I'm multiplying by 11. 11 times 11, they'll cancel out. I'm left with negative x equals negative 10 times 11, negative 110. So I'm going to multiply both sides by negative 1 to get rid of the minus, and I get x equals 110. Okay, so that was 9.2. Now let's look at 9.3. What do we have here in 9.3? I have a number touching a bracket. So when a number is touching the bracket, remember, we must do the distributive property first. Remember, I gave you that whole thing about equations. Don't call me after midnight. Okay, so the very first thing was the distributive property, where everything on the outside multiplies with everything on the inside, and we have to pay attention to the sign, the coefficient, and the variable. So if we have a look at 9.3, it's 4 bracket x plus 1 minus 3 bracket x subtract 3 equals negative 5x plus 12. So let's distribute. Everything on the outside multiplies everything on the inside. 4 times x is 4x. 4 times plus 1 is plus 4. Negative 3 times x is negative 3. Remember, we have to pay attention to the sign always. And then negative 3 times negative 3 is plus 9 equals negative 5x plus 12. Remember, this is an equation. Everything on the left-hand side must equal everything on the right-hand side. Do not be doing half the sum here and half the sum somewhere else. Okay, oh look, I forgot to write the x in there. How did I forget to write the x in there? Not good. Okay, so now I must look at my like terms. I have 4x, subtract 3x gives me 1x, plus 4 plus 9 is plus 13 equals minus 5x plus 12. Okay, so 1x plus 13 equals negative 5x plus 12. I need to get all my x's on the same side. So I've got negative 5x on this side, so what I'm going to do is I'm going to add 5x to both sides. So negative 5x plus 5x is going to leave me with nothing on this side. And what I do to the left, I do to the right, and what I do to the right, I do to the left. So if I added 5x to the right, I must add 5x to the left. So 1x plus 5x is 6x plus 13 equals, see the x's disappear, minus 5 plus 5 is nothing. So 6x plus 13 equals 12. Can you see we're back to a two-step equation? If you look at this, can you see it's got the same general form as this one over here? So now we're just left with the shoes and socks. So let's take off the shoes, which is adding 13. So we're going to subtract 13 from both sides. Okay. So then I've got on the right hand side 12 subtract 13. So I've left with 6x on this side because plus 13 minus 13 is nothing. 12 minus 13, negative 1. Now I'm going to divide both sides by 6. So x will be negative 1 over 6, and that is my final answer. So this one had the whole don't call me after midnight. First D, distributive property. Then we had to move the variable. See, we moved this minus 5x over to the other side. So distributive property, combine like terms. Sorry, I forgot the combine like terms. This was the combine like terms. 4x minus 3x gives you 1x. Then we moved the 5x over. Then we add and subtract, and then we multiply and divide. So this had the whole don't call me after midnight. Remember, don't call me after midnight. Distribute, combine, move, add and subtract, multiply, divide. Okay, now we're just left with 9.4, and 9.4 says 3x to the power 4 equals 243. So now the reverse of raising to a power is rooting. Okay, so if this is the fourth power, the inverse operation of to the fourth power is to the fourth root. But the thing is, the x is not by itself yet. Okay, so what we must do is get the x by itself. So I'm going to divide both sides by 3. So 3 divided by 3 is 1. And as a shortcut, I didn't write that, but I'm doing it here. Okay, so x to the power of 4 gives me 81, if your mental arithmetic is good. Now I need a number that is raised to the fourth power to give me 81. So x is my base. What base raised to the power of 4 gives me 81? So if you can use your calculator, you could type in what is the fourth root of 81. But if you don't know how to use your calculator, you just have to use logic. Okay, I'm going to show you what I mean by using logic in the corner here. What you do is you say, what is 1 to the power of 4? 1 times 1 times 1 times 1, which is 1. What is 2 to the power of 4? 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. What is 3 to the power of 4? 3 times 3 times 3 times 3. So 3 times 3 is 9, times 3 is 27, times 3 is 81. I have actually found out just by trying 3 different numbers that x is going to be 3. and then we go back and we check. And you could type this into your calculator, 3 times 3 to the power of 4, and you will come out and find that it is 243. But if you don't know how to use your calculator to find the fourth root, you can probably get the mark for this, okay? But just use logic. You know what to the power of 4 means. Just try numbers, because 81 is quite a small number. You will find whichever number it is fairly soon.